Hello everyone, today we'll review for test 1. First problem, solve each of the following equations for x. Part A, we have 4x minus 5 equal to 15. When we solve the equation for x, we try to get x by itself on the left side. So I can first of all add 4 to both sides. I get 4s equal to 20. Next, I can divide both sides by 4. If I divide both sides by 4, I get s equal to 5. Let's answer to part A. Part B, the equation is 3 times s plus 1 minus 11 equal to 10. We try to get s by itself. When there's parentheses, we can distribute first. If I distribute, I get 3x plus 3 minus 11 equal to 10. Next, I can try to combine like terms. Part of 3 plus negative 11 is negative a equal to 10. Next, I can add a to both sides. If I add a to both sides, I get 3x equal to 18. Next, I can divide both sides by 3. If I divide both sides by 3, I get s by itself. Here s is 18 divided by 3, which is 6. That's the answer to part B. Part C, we have 5x minus 6 equal to 3x minus 2. When we solve an equation for x, we try to get x by itself. But when we see x on the left side and right side, in general, try to group x to the left side first. So here I can subtract 3x from both sides. If I subtract 3x from both sides, on the right side here, positive 3x and negative 3x can cancel. What's left is negative 2. On the left side, 5x take away 3x is 2x. Minus 6 stays the same. Next, we try to get s by itself. So I can add 6 to both sides. If I add 6 to both sides, on the left side, 6 can cancel. We get 2s by itself. On the right side here, negative 2 plus 6 is positive 4. And then I can divide both sides by 2. If I divide both sides by 2, on the left side here I get s by itself. On the right side, 4 divided by 2 is 2. So the answer is 2. That's the answer to part C. Part D, we have 4 times s plus 2 minus 3 equal to 2 times 2 minus x minus 29. So in the equation, if we contain parentheses, let's distribute first. If we contain parentheses, let's distribute first. If I distribute 4, I get 4x plus a minus 3. If I distribute 2, I get 4 minus 2x minus 29. Next, combine like terms. Next, we combine like terms. A minus 3 is 5. On the right side, 4 plus negative 29. 4 plus negative 29 is negative 25. So I get negative 2x minus 25. Next, when we see x on the left side and right side, we try to group x to the left side of an equation. Here I can add 2x to both sides. If I add 2x to both sides, on the right side here 2x can cancel. We get negative 25 by itself. On the left side, 4x plus 2x is 6x plus 5 stays the same. Next, we try to get s by itself. Here I can subtract 5 from both sides. Then on the left side here, positive 5, negative 5 can cancel. We get 6s by itself. On the right side, negative 25 plus negative 5 is negative 30. Then I can divide both sides by 6. If I divide both sides by 6, s equal to negative 5. Negative 30 divided by 6 is negative 5. That's the solution to part D. Part E, 2 times absolute value of x minus 9 equal to 7. In the equation, if we contain absolute value, we need to isolate an absolute value first. So I can first put add 9 to both sides. Here on the left side, I get 2 times absolute value of x by itself. On the right side, 7 plus 9 is 16. Next, I can divide both sides by 2. If I divide both sides by 2, I get absolute value of x equal to a. If absolute value of x is a, that means x by itself must be either positive or negative a. If absolute value of x is a, that means what's inside is either positive or negative a. So there are two solutions, s equal to a or s equal to negative a. There are two solutions to this equation. S is either positive a or negative a. Part F, 4 times absolute value of x plus 1 minus 3 equal to 9. In the equation, if we contain absolute value, let's isolate absolute value first. So I can first put S3 to both sides. If I add 3 to both sides, on the left side, we get 4 times absolute value of s plus 1 by itself. 3 can cancel. On the right side, 9 plus 3 is 12. Next, I can divide both sides by 4. If I divide both sides by 4, on the left side, I get absolute value of s plus 1 by itself. On the right side, 12 divided by 4 is 3. So here we get absolute value of s plus 1 is 3. If absolute value of s plus 1 is 3, that means what's inside must be either positive 3 or negative 3. So the inside is either positive 3 or negative 3. So two cases, s plus 1 equal to positive 3 or s plus 1 equal to negative 3. Solve each equation for x. In the first equation, I can subtract 1 from both sides. I get s equal to 2. 3 minus 1 is 2. For the second equation, I can also subtract 1 from both sides. I get s equal to negative 4. So there are two solutions, s equal to 2, s equal to negative 4. That's the answer to part F. Number 2. Solve each of the following inequalities and write an answer in interval notation. Part A. We have 3x plus 4 is greater than or equal to 16. The way to solve equation and inequality is the same. We try to get x by itself on the left side. So I can first of all subtract 4 from both sides. I try to get s by itself on the left side. So I subtract 4 from both sides first. I get 3x greater or equal to 12. Next, I can divide both sides by 3. If I divide both sides by 3, on the left side I get s by itself. On the right side, 12 divided by 3 is 4. So I get s is greater or equal to 4. That's the solution for this inequality. But we need to write an answer in interval notation. For the answer in interval notation, let's draw the graph first. So the graph x is greater or equal to 4. Let's draw a number line first. Number line is always from negative infinity to infinity. 4 is somewhere on the line. And this 4 is included. Since there's equal sign here, this 4 is included. So we draw a solid point. X is greater or equal to 4. We know that for number to the right side of 4 is greater than 4. Answer to the right side of 4 is greater than 4. So select the region to the right side of 4. So that's the graph to this solution. Now for interval notation, look at the shaded region here. Left endpoint is 4. 4 is included. Use a bracket. Bracket means 4 is included. And right endpoint is infinity. We never include infinity. So always draw parentheses for infinity. We never include infinity. Always draw parentheses for infinity. So that's the interval notation. Number 4 is included. Infinity is not included. So that's the answer to part A. Part B. 5 minus 2 times x minus 3 is greater than 7. the way to solve for inequality is the same equation. We try to get s by itself on the left side. So when there's parentheses, we can try to distribute first. When there's parentheses, we can distribute first. If I distribute -2, I get -2x plus 6 is greater than 7. Then I can combine like terms. 5 plus 6 is 11. I got 11 minus 2x is greater than 7. We took s by itself on the left side. So I can subtract 11 from both sides. If I subtract 11 from both sides, on the left side I get -2x by itself. On the right side, 7 minus 11 is -4. Then next I can divide both sides by -2. Now here be very careful. For inequalities, when we multiply or divide by negative number, we have to switch the direction of inequality sign. For inequalities, be very careful. When we multiply or divide inequality by negative numbers, we must switch the direction of inequality sign. So here greater than become less than. On the left side, -2 get cancelled, we get s by itself. On the right side, -4 divided by -2 is +2. So the solution is x less than 2. That's the solution to this inequality. Next, we try to write an answer in interval notation. Let's draw number line first. Number line is always from -infinity to infinity. 2 is somewhere in the line. Since this number 2 is not included, draw open circle. And we know that number to the left side of 2 is less than 2. So shared region to the left side of 2. Shared region to the left side of 2. This number to the left side of 2 is less than 2. So shared region to the left side of 2. Now for interval notation, for the shaded region here, left endpoint is -infinity. Right endpoint is 2. And here 2 is not included. Draw open circle. Draw parentheses. 2 is not included. Draw parentheses. That's the answer to part B. Part C. 1 is less than 5x minus 9 is less or equal to 16. 1 is less than 5x minus 9 is less than or equal to less than or equal to 16. We try to get s by itself in the middle. For inequality with 3 parts, we try to get s by itself in the middle. So here what we can do is I can first put add 9 to both sides. I can eliminate 9 first, then eliminate 5, get s by itself. So let me first add 9 to all 3 parts. Add 9 to all 3 parts. On the left side here, 1 plus 9 is 10. In the middle, positive 9, negative 9 can cancel, we get 5s by itself. On the right side, 16 plus 9 is 25. Next, I can divide all 3 parts by 5. If I divide all 3 parts by 5, in the middle I get s by itself. On the left side, 10 divided by 5 is 2. On the right side, 25 divided by 5 is 5. So s is between 2 and 5. Number 5 is included. That's the answer to this inequality. For the answer in interval notation, let's sketch the graph first. From infinity to infinity. 2 and 5, they are somewhere in the number line. 2 is on the left, 5 on the right. Since 2 is not included, draw open circle. 5 is included, draw solid circle. S is between 2 and 5. That's a region between 2 and 5 here, in the number line. That's a graph. Now for the answer in interval notation, number 2 is not included, that's the left endpoint. And number 4 is included, that's the right endpoint. That's an answer in interval notation. Part D. 2 is less than a minus 3x less or equal to 17. When we solve inequality with 3 parts, we try to get s by itself in the middle. So I can first of all eliminate a first, then eliminate -3 and get s by itself. So I can first of all subtract a from all 3 parts. If I subtract a from all 3 parts, in the middle I get -3x by itself. On the left side, 2 minus 8 is -6. On the right side, 17 minus 8 is +9. Next, we try to get s by itself in the middle. I can divide all 3 parts by -3. if I divide all three parts by negative number, for inequalities, if I divide inequality by negative number, I need to switch the direction for inequality sign. So less than become greater than, less than become greater than, less than equal to become greater than equal to. If I divide in the middle, negative 3 can cancel. Okay, as by itself. On the left side here, negative 6 divided by negative 3, double negative is positive. 6 divided by 3 is 2. On the right side here, positive 9 divided by negative 3, positive number divided by negative number is negative. 9 divided by 3 is 3. And in general here, negative 3 is smaller, 2 is larger. In general, for inequality with 3 parts, we want a smaller number on the left. So in general, write it as negative 3 is less or equal to x is less than 2. In general, write smaller number on the left, larger number on the right. Write it as negative 3 is less or equal to x less than 2. Then that's the answer to this inequality. Next, we'll run the answer in interval notation. So let's draw the graph first. If we draw the graph, that's a number line from infinity to infinity. Negative 3 is somewhere here in the number line. 2 is somewhere here in the number line. Negative 3 is smaller, 2 is larger, so put negative 3 on the left, 2 on the right. And negative 3 is included, draw solid point for negative 3. 2 is not included, draw open circle for 2. Here x is between negative 3 and 2, so trade region between negative 3 and 2. That's a graph of this solution. Now for interval notation, for the straight region here, left endpoint is negative 3, right endpoint is positive 2. Negative 3 is included, 2 is not included. Parenthesis means number 2 is not included. Bracket means negative 3 is included. That's the answer to part D. Number 2, part E. Absolute value of 2x minus 7 is less or equal to 5. When we have absolute value is less than some positive number, always take the inside. Take 2x minus 7, make it between positive 5 and negative 5. Then we should take x by itself in the middle. So I need to eliminate 7 first, then eliminate 2. Let me eliminate 7 first. I can add 7 to all 3 parts. Add 7 to all 3 parts. So in the middle, 7 can cancel, get 2x by itself. In the left side, negative 5 plus 7 is 2. In the right side, 5 plus 7 is 12. Next, I can divide all 3 parts by 2. If I divide all 3 parts by 2, I get x by itself in the middle. In the left side, 2 divided by 2 is 1. In the right side, 2 divided by 2 is 6. So the answer is x between 1 and 6. Next, for the answer in interval notation, let's draw the graph first. For the answer in interval notation, let's draw the graph first. Number lines from net infinity to infinity. S is between 1 and 6. So let's find 1 and 6 on the line. 1 is here, 6 is here. Since 1 and 6 they are both included, draw solid point for 1 and 6. Since x is between 1 and 6, straight region between 1 and 6. That's the graph. And for the answer in interval notation, for the straight region here, left endpoint is 1. Right endpoint is 6. Since they are both included, draw brackets. That's the answer to part E. F. Absolute value of 3x minus 7 is greater than 9. When we have absolute value is greater than some positive numbers, take what's inside. Take what's inside. 3x minus 6, make it less than negative 9, or 3x minus 6, make it greater than 9. Make it inside either less than negative 9 or greater than positive 9. Then solve both of them. Solve both of them, get x by itself. For the first inequality, I can add 6 to both sides. If I add 6, I get 3x by itself on the left side. on the right side. Negative 9 plus 6 is negative 3. Next, we can divide both sides by 3. If I divide both sides by 3, I get s by itself on the left side. On the right side here, negative 3 divided by positive 3 is negative 1. So the solution for the first inequality is x less than negative 1. Next, solve the second inequality. So I can first put s6 to both sides. I get 3x is greater than 15. 9 plus 6 is 15. Next, I can divide both sides by 3. If I divide both sides by 3, I get x is greater than 5. So s is either less than negative 1 or s is greater than 5. That's the answer to this inequality. Next, for the numbers in interval notation, let's draw number line first. Number line is always from negative infinity to infinity. Let's first of all put these two numbers on the number line. Negative 1 is smaller, 4 is larger. Put a smaller number on the left, larger number on the right. Since negative 1 and 5 are not included, draw open circle for both of them. Draw open circle for both of them. Now, for the first inequality, x is less than negative 1. We know that number to the left of negative 1 is less than negative 1. For the second inequality, it says s is greater than 5. We know that number to the right side of 5 is greater than 5. So choose the region to the right side of 5. And then, for the answer in interval notation, we must include both pieces. First piece is from negative infinity to negative 1. Negative 1 is not included. Second piece is from 5 to infinity, and 5 is not included. If there are two intervals, put union in the middle. That's an answer in interval notation. That's the final answer in interval notation. Part G. 5 minus 4 times absolute value of x is less or equal to negative 3. In an inequality, if we contain absolute value, we try to isolate the absolute value first. Here I can first subtract 5 from both sides. If I subtract 5 from both sides, I get negative 4 times absolute value of x is less or equal to negative a. Next, I can divide both sides by negative 4. For inequality, be very careful. When we multiply or divide inequality by a negative number, we must switch the direction of inequality sign. Here, less than become greater than. Here on the left side, negative 4 cancel, we get absolute value of x by itself. On the right side, negative a divided by negative 4, double negative is positive. A divided by 4 is 2. We get absolute value of x is greater or equal to 2. Now when we have absolute value is greater than some positive number, take what's inside. Make what's inside is either less than negative 2 or greater than or equal to positive 2. Then in both inequalities here, we get x by itself already. So that's the solution to this inequality. Now, for the answer in interval notation, let's sketch the graph first. Draw number line from negative infinity to infinity. Negative 2 is somewhere in the line. Positive 2 is larger than negative 2, so put it on the right side. It's negative 2, that's positive 2. X is less or equal to negative 2. We know that the region to the left side of negative 2 is less than negative 2. So choose the region to the left side of negative 2. For the second inequality, s is greater than 2. We know that number to the right side of 2 is larger than 2. So choose the region to the right side of 2. That's the solution to this inequality. Now, for the answer in interval notation, there are two shaded regions here. First region is from negative infinity to negative 2. Negative 2 is included. Second region is from 2 to infinity. 2 is included. If there are two intervals, put union in the middle. H. 3 times absolute value of s plus 5 plus 2 is less than 14. In an inequality, if it contains absolute value, let's isolate absolute value first. So I can first subtract 2 from both sides. If I subtract 2 from both sides, I get 3 times absolute value of s plus 5 is less than 12. Next, I can divide both sides by 3. If I divide both sides by 3, on the left side, I get absolute value of s plus 5 by itself. On the right side, 12 divided by 3 is 4. When we have an absolute value is less than some positive number, take what's inside, s plus 5, make it between -4 and +4. Next, try to get s by itself in the middle. I can subtract 5 from all 3 parts. If I subtract 5 from all 3 parts, in the middle I get s by itself. In the left side here, -4 plus -5 is -9. In the right side, 4 plus -5 is -1. So I get s by itself in the middle. So that's a solution to this inequality. Next, let's write the answer in interval notation. First of all, let's sketch the graph. S is between number lines from -infinity to infinity. S is between -9 and -1. Let's first of all put these two numbers on the number line. -9 is smaller. -1 is larger. Put smaller number on the left side. Put larger number on the right side. Here, S is between -9 and -1. So choose the region between -9 and -1. That's a graph for this inequality. And then for the answer interval notation, look at the shaded region here. For the shaded region, left endpoint is -9. And -9 is not included. Right endpoint is -1. Also, -1 is also not included. That's the answer in interval notation. Number 3. Find the x and y intercepts for each of the following equations. Part A. The equation is 4x plus y equal to 12. We try to find the x and y intercepts. So for x intercept, we set y equal to 0. And solve the equation for x. Set y equal to 0 means I plug in 0 for y, then solve for x. I get 4x plus 0 equal to 12. Plug in 0 for y, and then solve for x. We know that 4x plus 0 is 4x equal to 12. Next, I can divide both sides by 4. If I divide both sides by 4, I get s equal to 12 divided by 4. 12 divided by 4 is 3. So the s-intercept is 3, 0. S-intercept is 3, 0. For the y-intercept, we set s equal to 0 and solve the equation for y. Set s equal to 0, then solve the equation for y. We have 4 times 0 plus y equal to 12. We know that 4 times 0 is 0. We get 0 plus y is 12. And we know that 0 plus y is the same as y. So we get y equal to 12. So for the y-intercept, we have 0, 12. Write s coordinate first, and then y coordinate. When we write a point, write s coordinate first, and then write y coordinate. Y coordinate here is 0, 12. Part B. The equation is x plus y squared equal to 9. The equation is s plus y squared equal to 9. We're looking for the s and y intercepts for the graph of this equation. Let's find s-intercept first. For the s-intercept, set y equal to 0. Plug in 0 for y, then solve for x. We have x plus 0 squared equal to 9. 0 squared is 0. Then we know that x plus 0 is x. We get s equal to 9. So the s-intercept is 9, 0. Next, let's find a y-intercept. For the y-intercept, we set s equal to 0. For the y-intercept, set s equal to 0. We plug in 0 for x, and then solve the equation for y. If I plug in 0 for x, I get 0 plus y squared equal to 9. And we know that 0 plus y squared is y squared. If y squared is 9, then y must be either positive 3 or negative 3. If y squared is 9, square root of 9 is 3. So here y could be either positive 3 or negative 3. There are two solutions for y. So that means there are two y-intercepts. For y-intercept, here s is always 0. So we get 0, negative 3, and 0, 3. That's the y-intercept. That's the answer for part B. Part C. The equation is 3 times absolute value of x plus y equal to 6. We try to find the x and y intercepts. For x-intercept, we set y equal to 0, then solve for x. If I set y equal to 0, I plug in 0 for y. I get 3 times absolute value of x plus 0 equal to 6. We know that 3 times absolute value of x plus 0 is the same as 3 times absolute value of x equal to 6. Next, I can divide both sides by 3. If I divide both sides by 3, we get absolute value of x equal to 2. If absolute value of x equal to 2, that means x itself is either positive or negative 2. If absolute value of x is 2, that means what's inside is either positive 2 or negative 2. So we got two solutions for x. That means we have two x-intercepts. Which is negative 2, 0, y 0, and 2, 0. Those are the x-intercepts. Next, we try to find a y-intercept. For the y-intercept, we set s equal to 0. We set s equal to 0. Plug in 0 for x, and then solve the equation for y. If we plug in 0 for x, we get 3 times absolute value of 0 plus y equal to 6. We know that absolute value of 0 is 0. 0 times 3 is 0. We get 0 plus y equal to 6. And we know that 0 plus y is y. So we get y equal to 6. That's the solution for this equation. That means y-intercept is 0, 6. Write x coordinate first, then y coordinate. That's the x-intercept. That's the y-intercept. 0, 6. Part D. The equation is s squared minus y squared equal to 4. We try to find the x and y intercepts. For x-intercept, we set y equal to 0. Set y equal to 0. Then solve the equation for x. If I plug in 0 for y, we get s squared minus y squared equal to 4. If I plug in 0 for y, I get 0 squared here. If I plug in 0 for y, I get 0 squared. S squared minus 0 squared equal to 4. And we know that 0 squared is 0. S squared minus 0 is the same as s squared. If s squared is 4, then s by itself is either positive or negative 2. Square root of 4 is 2. So x by itself is either positive or negative 2. So that's the solution is the S-intercept. Since there are two solutions, we have two S-intercepts. S-intercept here is -2, 0 and 2, 0. S could be either positive 2 or -2. Y is always 0. That's an S-intercept. Next, for the Y-intercept, we say S equal to 0. Plugging 0 for X, we get 0 squared minus Y squared equal to 4. 0 squared is 0. 0 minus Y squared is -Y squared equal to 4. If there's no coefficient in the front, we can consider there's a 1 here. Consider this as -1 times Y squared equal to 4. Next, I can divide both sides by -1. If I divide both sides by -1, I get Y squared equal to -4. We know that perfect square cannot be negative. Y squared here is a perfect square. Perfect square cannot be negative, so there are no solution for Y. If there's no solution for Y, means there are no Y-intercepts. Since there are no solutions, that means there are no Y-intercepts. Y squared cannot be negative. A perfect square can never be negative. Since there are no solutions for Y, there's no Y-intercepts. Number 4. Find the center and the radius for each of the following equations of circles. Part A. X squared plus Y squared minus 4x minus 6y minus 3 equal to 0. In order to find the center and the radius of a circle, we need to first of all rewrite the equation in the standard form. The standard form of the equation of a circle looks like this. X minus h squared plus y minus k squared equal to r squared. That's the standard form of the equation of a circle. In the standard form here, h and k represent the center of the circle, and r represents radius. So let's first of all rewrite this equation in the standard form. So first step, we try to group x and y together. Put x in one parenthesis, group x together, and group y together, y squared minus 6y. Group x together, group y together, then move the constant, move the number to the other side. If I move -3 from the left side to the right side, -3 becomes +3. Next, we try to complete square for each of them, for x and y. Try to complete squares. X squared minus 4x. Try to add a term here to make perfect square. For y squared minus 6y. Try to add a term here to make perfect square. So in order to make perfect square, take the middle number, divide by 2, and then square. The middle number here is -4. If we take -4 divided by 2, we get -2. And then -2 square is +4. So I can add 4 to both sides. Add 4 here, add 4 on the other side. Add 4 on the left side and right side. Do the same thing for the other parentheses. We have -6 in the middle. If we take -6 divided by 2, we get -3. And then square this number. -3 squared is +9. Then we can add 9 to both sides. Add 9 to the left side, add 9 to the right side. After we complete squares, try to factor each of them. S squared minus 4x plus 4. If we factor, we try to find two numbers that they multiply to be 4. Add to be -4. Which we can use this number, -2, -2. -2 times -2 is +4. -2 plus -2 is -4. And x minus 2 times s minus 2 together is s minus 2 squared. If they look exactly the same, we write x minus 2 squared. That's how we complete squares here. It's s minus 2 squared. For the second parenthesis, do the same thing. Try to factor y squared minus 6y plus 9. So try to factor this. Put y on each parenthesis. Then try to find two numbers that they multiply to be 9 and they add to be negative 6. We can try to use this number here. Negative 3. We know that negative 3 times negative 3 is positive 9. And negative 3 plus negative 3 is negative 6. So this two number works. When we have y minus 3 times y minus 3, that can be rewritten as y minus 3 squared. On the other side, 3 plus 4 is 7. 7 plus 9 is 16. That's the equation of a circle in a standard form. That's the equation of a circle in a standard form. Now try to match what's h and k. Try to find out what's h and k. Here, both h and k has negative in the front, has negative sign in the front. Both h and k has negative sign in the front. So for both number 2 and 3, take an opposite sign. Here, 2 is negative, take opposite sign. 3 is negative, take opposite sign. That's the center of the circle. And then from the radius, if we try to match the formula, we can see that r squared is 16. If I take square root, r must be 4. So that's the center of the circle. That's the radius of the circle. That's the answer to part A. Part B. We have x squared plus y squared minus ax plus 10y minus 11 equal to 0. Find the center and radius of the circle. So the same procedure. First step, try to group x together and group y together. If I group x together, I get x squared minus ax. If I group y together, I get y squared plus 10y. And then move this single number to the other side. Move the single number to the right side. So when I move negative 11 over, it becomes positive 11. Next, try to complete squares. We have x squared minus ax. Try to add something to make perfect square. Next we have y squared plus 10y. Try to add something here to make perfect square. On the other side, leave 11 the same. Now, try to add something here, make perfect square. What should we add? Same procedure. Same procedure. Take negative a, divide by 2. I get negative 4. Then take negative 4 squared. I get 16. So add 16 to the left side, add 16 to the right side. Then for number 10, do the same thing. For the second parenthesis, middle number is number 10. Do the same thing. Take 10 divided by 2 is 5. Then take 5 squared. I get 25. Add 25 to the left side and the right side. Then factor this. x squared minus ax plus 16. If I factor, what do we get? x squared minus ax plus 16. If I factor, I first of all write two parentheses. Put x on each parenthesis. Then find two numbers. They multiply to be 16 and add to be negative a. We can use this number here, negative 4. Negative 4 times negative 4 is positive 16. And negative 4 plus negative 4 is negative a. When we have negative x minus 4 times s minus 4, it can be rewritten as s minus 4 squared. Do the same thing for the second parenthesis. Factor y squared plus 10y plus 25. First of all, draw two parentheses. Put y's on each parenthesis first. And then find two numbers. When we multiply, we get 25. When we add, we get positive 10. We can try this number here. 5 times 5 is 25, and 5 plus 5 is 10. Then since we get y plus 5 twice, we can write it as y plus 5 squared. So if I factor this, I get y plus 5 squared. On the right side here, 10 plus 11 plus 16 is 27. 27 plus 25 is 52. That's in the standard form. That's the standard form of equation of a circle. Now try to match what's the center, what's the radius. Now try to match h and k first. Since for h and k they both have negative sign in front, so take an opposite sign. For 4 and 5, take opposite sign. For negative 4, I use positive 4. For positive 5, I use negative 5. That's the center of a circle. 4, negative 5. For the radius, if we try to match the formula, we can see that r squared is 52. If r squared is 52, for r, we take square root. Square root of 52 can be rewritten as square root of 4 times square root of 13. Square root of 4 is 2. 13 is irreducible and leave it the way it is. So that's the radius of a circle. 2 square root of 13. That's the center of a circle. 4, negative 5. That's the answer for part B. Number 5. Find the equation of a circle in the standard form. Part A. Find the equation of a circle, center and point 2, 0, with radius square root of 11. Let's first write down the standard form of equation of a circle first. The standard form of equation of a circle looks like this. X minus h squared plus y minus k squared equal to r squared, where the center of the circle is h, k, and the radius of the circle is r. So h, k represent the center of the circle. R represents the radius of the circle. So for part A, we know that the center of the circle is 2, 0. That's h, that's k. And radius is square root of 11, that's r. So we plug in. We have x minus h squared plus y minus k squared equal to r squared. If we plug in h, k, and r, we have x minus 2 squared plus y minus 0 squared equal to square root of 11 squared. Plug in h, k, and r. Here, the center 2, 0 represent h and k. Radius is r, so r is square root of 11. Then simplify. I get s minus 2 squared plus y minus 0 is the same as y. So I get y squared here. Square root of 11 squared. Square cancel square root. Answer is 11. So that's the standard form of a circle, of an equation of a circle. That's an answer to part A. Part B. Find the equation of a circle. Centered and a point 2, negative 1 with diameter A. In order to find equation of a circle, we need to know the center and radius. In part B, we know the center already. What's missing is the radius. If the diameter is A, here we know center is 2, negative 1. If the diameter is A, what's the radius? We know that radius is half of the diameter. Radius is always half of the diameter. Diameter is A. A divided by 2 is 4. So when the diameter is A, radius of the circle is 4. Then plug in. Equation of a circle is x minus h squared plus y minus k squared equal to r squared. That's the standard form of equation of a circle. Then plotting h and k and r. H is 2, k is -1, I get y minus -1, r is 4. Then simplify, I get s minus 2 squared plus y minus -1. Double negative is positive. I get y plus 1 squared equal to 4 squared. 4 squared is 16. That's the equation of a circle in the standard form. That's the answer to part B. Part C. Find the equation of a circle. Center and a point -1, 3 with a point (3, 4) on the circle. Find the equation of a circle. Center and a point -1, 3 with a point 3, 4 on the circle. So in order to find equation of a circle, we must know the center and the radius. In part C here, we know that the center of a circle is -1, 3. We know the center already. What's missing is the radius. How do we find the radius? In part C, we know the center, and we know a point on the center. In order to find the radius, try to find the distance between center and the point. Try to find distance between the center and the point. Distance from center to the edge of a circle. That's a radius. So for radius, for the distance between these 2 points, between the center and the point on the circle, distance formula is x2 minus s1 squared plus y2 minus y1 squared, all under a square root. In general, we call the first point s1, y1, and we call the second point s2, y2. Plug in s2 minus s1, we have 3 minus -1 squared plus y2 minus y1 squared. y2 is 4, y1 is 3 squared. Then simplify. 3 minus -1. Double negative is positive. 3 plus 1 is 4. I get 4 squared plus 4 minus 3 is 1. That's 1 squared. 4 squared is 16. 1 squared is 1. 16 plus 1 is 17. So that's square root of 17. R is square root of 17. That's the radius of a circle. Once we know the center, we know the radius, we can plug in to find equation of circles. Equation of circle is x minus h squared plus y minus k squared equal to r squared. Plug in the center and radius. Here center is -1 and 3. So h is -1, k is 3. R is square root of 17. Then simplify here. Double negative is positive. We get s plus 1 squared plus y minus 3 squared. For square root of 17 squared, we know that in general, square cancels square root. That's 17. That's an equation of circle in the standard form. That's an equation of a circle in the standard form. That's the answer to part C. Part D. Find the equation of a circle with 2, -3, -4, and 5 as the endpoint of a circle. Find the equation of a circle. Find the equation of a circle with points 2, -3 and -4, 5 as points of in a diameter. So, in order to find equation of a circle, we must know the center and the radius. How do we find the center here? In this problem, in part D, center is not given. How do we find the center? Part D, we know that the endpoint of diameter is these 2 points. If we know the endpoint of diameter, we can find the midpoint. I can find the midpoint of these 2 points, and the midpoint of these 2 points is the center of a circle. So let's first of all find the center of the circle, which is the midpoint. And the formula for midpoint is x equal to s1 plus s2 over 2, y equal to y1 plus y2 over 2. That's the formula for the midpoint. The midpoint of these 2 endpoints is the center of the circle. This is a diameter. Midpoint of the diameter is the center of the circle. When there are 2 points, usually we call the first point S1, Y1. We call the second point S2, Y2, and plug in S1 plus Y1, S1 plus S2. That's 2 plus -4 over 2. 2 plus -4 is -2. -2 divided by 2 is -1. That's the S coordinate of the center. On the y coordinate of the center, do the same thing. Y1 plus Y2 divided by 2. That's -3 plus 5. Y1 plus Y2, -3 plus 5 over 2. -3 plus 5 is positive 2. 2 divided by 2 is 1. So the center of the circle is a point -1, 1. That's the center of the circle. Next, try to find the radius of the circle. We know that one of the points on the circle is 2, -3. Center of the circle is -1, 1. Distance from the center to one of the endpoint of diameter, that's the radius. Distance from the center to a point on the edge of a circle is the radius. So I can find distance from this point to the center. So let me find distance between the 2 points. Let me call this point S1, Y1. Call this point S2, Y2. Distance between 2 points is the radius. And the distance formula is S2 minus S1 square. -1 minus 2 square plus y2 minus y1 square. 1 minus -3. y2 minus y1 square. 1 minus -3 square. -1 minus 2 is -3. In the second parenthesis, double negative is positive. 1 plus 3 is 4. -3 squared is 9. 4 squared is 16. 9 plus 16 is 25. Square root of 25 is 5. That's the radius of the circle. Once I know the center, I know the radius. I can find the equation of the circle. Formula is x minus h squared plus y minus k squared equal to r squared, where h and k represent the center of the circle, r represent the radius of the circle. Then plug in. We have x minus -1 squared plus y minus 1 squared equal to r squared. Here r is 5. So I get 5 squared here. Then simplify. Double negative is positive. We get s plus 1 squared plus y minus 1 squared equal to 5 squared. 5 squared is 25. That's an equation of the circle in the standard form. That's an answer to part D. Number 6. Find the slope and the y-intercept for each of the following equation of lines. Part A. 4x minus 2y equal to 3. In order to find the slope and the y-intercept, we first of all rewrite the equation in the slope-intercept form first. Slope-intercept form of the equation of a line looks like this. Y equal to ms plus b. M is called the slope. B is called the y-intercept. So, in order to find the slope and the y-intercept, we first of all try to rewrite the equation in its form first, which means get y by itself. Then the number in front of x is the slope, and a single number by itself is the y-intercept. So let's try to isolate y. I can first of all subtract 4x from both sides. If I subtract 4x from both sides, I get negative 2y equal to negative 4x plus 3. In general, put x, write x in the front. Write negative 4x plus 3. Next, try to get y by itself. Here I can divide both sides by negative 2. If I divide both sides by negative 2, I get y by itself on the left side. On the right side here, negative 4 divided by negative 2 is positive 2. X stays the same. Then positive 3 divided by negative 2 is negative 3 over 2. Once I get y by itself, the number in front of x is the slope. Number in front of x is the slope. The single number by itself is the y-intercept. That's the y-intercept. So the slope is 2. The number in front of x is the slope. The y-intercept is this number, negative 3 over 2. Negative 3 over 2. In general, for the y-intercept, for any y-intercept, its x-coordinate is always 0. For any y-intercept, its x-coordinate is always 0. So write 0, comma, negative 3 over 2. 0, comma, negative 3 over 2. That's the y-intercept. That's the y-intercept. For y-intercept, its x-coordinate is always 0. So we write 0, comma, negative 3 over 2. That's the y-intercept. Part B. 2x plus 5y equal to 15. Find the slope and the y-intercept. So first of all, try to rewrite the equation, put it in the form of put it in the slope-intercept form first. That means get y by itself. I can first of all subtract 2x from both sides. If I subtract 2x from both sides, I get 5y equal to negative 2x plus 15. Next, I need to get y by itself. So I divide both sides by 5. If I divide both sides by 5, on the left side I get y by itself. On the right side, negative 2 divided by 5 is negative 2 over 5. Leave x by itself. Then we have positive 15 divided by 5. Positive 15 divided by 5 is positive 3. Once I get y by itself, the number in front of x is the slope, and the single number by itself is the y-intercept. So here the slope is negative 2 over 5. And the y-intercept is 0, comma 3. For the y-intercept, its x-coordinate is always 0. So we write 0, comma 3. That's the answer to part B. Number 7. Find the equation for each of the following lines and write the answer in the standard form. Part A. Find the equation of a line with slope 4 and passing through a point 5, comma negative 2. So for equation of a line, there are 3 different forms. First form is called a standard form. Standard form looks like this. It's in the form of ax plus by equal to c. This is called a standard form. ax plus by equal to c. That's called a standard form. Another form is called a slope intercept form. Slope intercept form looks like this: y equal to mx plus b. And another form is called a point slope form. Point slope form looks like this: y minus y0 equal to m times x minus x0. That's called a point slope form. In point slope form, x0, y0 represent a point on the line. M represent the slope. That's why it's called point slope form. x0, y0 represent a point on the line. M represent the slope of the line. That's why it's called point slope form. In general, when we try to find equation of a line, we try to use either slope intercept form or point slope form. And then we write the final answer in the standard form. So we use these two forms to find equation of lines first, and then write the answer in the standard form. Now let's answer the question here. Find the equation of a line with slope 4 and passing through a point 5, -2. We can use either the slope intercept form or point slope form. Let me use the point slope form first, then I'll show you the slope intercept form. If I use the point slope form, first of all, write down the equation: y equal to ms plus b. We know that m is 4. We need to find b. How do we find b here? We plug in the point 5, -2 for x and y. Plug in the point 5, -2 for x and y. Once I plug in slope and the point, I can find b. Once I plug in s, y, and m, I can solve for b. So let's plug in. Y is -2, m is 4, x is 5. Plus b. And then 4 times 5 is 20. In order to solve for b here, I can subtract 20 from both sides. If I subtract 20 from both sides, I get b equal to -22. Now I know m, I know b. I can plug in m and b, find the equation of line. Y equal to 4x minus 22. Then for the answer in the standard form, we move x and y to the left side. Move the single number on the right side. We need to move x and y to the left side and leave the single number on the right side. So here I can subtract 4x from both sides. If I move 4x over, positive 4x becomes negative 4x. I get negative 4x plus y equal to -22. If I move positive 4x from right side to the left side, I change the sign. It's positive, I make it negative. If it's negative, I make it positive. In general, for the answer in the standard form, we try to make the first number positive. So I can multiply both sides by -1. Multiply both sides by -1 means change the sign for every number. It's 4x minus y equal to positive 22. That's an answer in standard form using slope intercept form. If I use the point slope form, I can get the same answer. I can get exactly the same answer. If I use the point slope form, I'll get exactly the same answer. Write down the formula first. Formula is y minus y0 equal to the slope times x minus x0. Here we know that the slope is 4. And the point here is 5, -2. If I use point slope form, this point 5, -2, it represents x0, y0. If we use point slope form, this point 5, -2 represents x0, y0. So plug in, we have y minus y0, y0 is -2, equal to m, m is 4, times x minus x0, x0 is 5. Then simplify. Double negative is positive. I get y plus 2. On the right side, distribute 4. I get 4x minus 20. That's the equation of a line. if I try to put the answer in the standard form, I move x and y to the left side, move all numbers to the right side, move s and y to the left side, move all numbers to the right side. Now here, if I move 4x from the right side to the left side, changing the sign, it's positive. When I move over, it becomes negative. I get negative 4x plus y. Then move number 2 from left side to the right side. Positive 2. When I move over, it becomes negative 2. Then negative 20 minus 2 is negative 22. In general, for the final answer, we try to make the first number positive. So I multiply both sides by negative 1. If I multiply both sides by negative 1, every turn, the sign for every turn will be switched. So it becomes 4x minus y equal to positive 22. That's the equation of a line in the standard form. So either using slope intercept form or point slope form, we get exactly the same answer. Either way is okay. Either doing the first form or second form, we get exactly the same answer. Part B. Find the equation of a line passing through points 1, 3 and 7, 1. When we try to find the equation of a line, if the slope is unknown, we need to find the slope first. The formula for the slope is y2 minus y1 over s2 minus s1. If we know 2 points, we can use this formula to find the slope of a line. So here we know 2 points, 1, 3 and 7, 1. In general, we call the first point s1, y1. And we call the second point s2, y2. Then plug in. The slope is y2 minus y1, 1 minus 3 over s2 minus s1, 7 minus 1. On the numerator, 1 minus 3 is negative 2. On the denominator, 7 minus 1 is 6. We know that negative 2 divided by positive 6, answer is negative. 2 over 6 can be reduced as 1 over 3. I can divide top and bottom by 2. 2 over 6 can be reduced as 1 over 3. That's the slope of the line. Once we know the slope, we can use slope intercept form or point slope form to find equation of line. Let me do both ways. Let me first of all use the slope intercept form. Y equal to ms plus b. Slope is negative 1/3. So we need to find b here. Since I know m, we need to find b. For x and y, we can pick any point. We plug in s and y and then find b. For s and y, we can pick any point. Here, first point looks like numbers are smaller. So I pick 1, 3 to be the point. So for this point, 1 is x, 3 is y. Then plug in. Y equal to 3. M is negative 1/3. X is 1 plus b. Simplify. I have 3 equal to negative 1/3 plus b. In order to get b by itself, I can add 1/3 to both sides. Add 1/3 to both sides. On the right side, I get b by itself. On the left side, I get 3 plus 1/3. 3 plus 1/3. What's 3 plus 1/3? For 3 plus 1/3, I can first of all write 3 as 3 over 1. Then find the least common denominator. Least common denominator is 3. So for the first fraction, I can multiply top and bottom by 3. I get 9 over 3. Second fraction is 1 over 3. 9 over 3 plus 1 over 3 is 10 over 3. That's b. b is 10 over 3. Once I know m, I know b. I can plug in m and b for the equation of line. So y equal to negative 1/3 of x plus 10 over 3. That's the equation of a line. Next, try to write this answer in the standard form. In order to write this in standard form, we need to move x and y to the left side and keep the number on the right side. When I move negative 1/3 of x over, it becomes positive 1/3 of x. positive 1/3 of x plus y equal to 10/3. And in general, we prefer to use whole numbers. And since the denominator is common denominator is 3, we multiply every term by 3. Multiply both sides by 3. 3 times 1/3. It cancels 3 on the bottom. I get s by itself. 3 times y is 3y. 10/3 times 3. 3 cancels 3 on the bottom. I get 10 by itself. That's an answer in the standard form. Here I use slope intercept form. Or we can use point slope form, which get exactly the same answer. If we use point slope form, which get exactly the same answer. Formula for point slope form is y minus y0 equal to m times x minus x0. Here, slope is negative 1/3. And a point on the line. For a point on the line, you can use either point. You can use either the first point or the second point. Since I picked the first point when I use slope intercept form, here I'll choose the second point, 7, 1 from the point slope form. When I pick 7, 1, 7 represents x0, 1 represents y0 in point slope form. The point here, 7 represents x0, 1 represents y0. Then plug in. We get y minus 1 equal to negative 1/3 times x minus x0. x0 is 7. That's the equation of the line. Now, for the final answer, try to put it in the standard form, which means we try to make everything to be whole number. We don't want fraction here. So let me first of all multiply both sides by 3. I try to eliminate the denominator here. Let me first of all multiply both sides by 3. If I multiply both sides by 3, on the left side, I get 3 times y minus 1. On the right side, if I multiply negative 1/3 by 3, 3 cancel denominator, I get negative 1 times x minus 7. Then I can distribute 3 and distribute negative 1. If I distribute 3, I get 3y minus 3 on the left side. If I distribute negative 1, I get negative x plus 7. Then for the answer in the standard form, try to move x and y to the left side, numbers to the right side. If I move negative x over, it becomes positive x plus 3y. Positive x plus 3y. 3y stays the same. If I move negative 3 over, it becomes positive 3. So I get 7 plus 3. Number 7 stays on the right side. If I move negative 3 over, it becomes positive 3. And then 7 plus 3 is 10. That's the answer in the standard form. That's an answer in the standard form. Part C. Find the equation of the line parallel to the line y equal to 2x plus 5 and passing through a point 1, negative 2. In general, when we try to find equation of a line, we need to know the slope first. If we know 2 points, we can use the formula y2 minus y1 over s2 minus s1 to find the slope. However, in this problem, there's only 1 point. That means we cannot use this formula. We cannot use this formula. But in this problem, we know a parallel line. So we can use this line as a reference to find the slope of the line. For the parallel line here, y is 2x plus 5. So the slope for this line is 2. These two lines are parallel, their slope must be the same. These two lines are parallel, their slope must be the same. So for slope, we use exactly the same slope here. These two lines are parallel, their slope exactly the same. The slope of this line is 2. And since this is a parallel line, the slope must be exactly the same. So slope is 2. Once I know the slope, we can find equation of the line. We have two choices. We can use slope intercept form and point slope form. We have two choices. Let me show you the slope intercept form first. Y equal to ms plus b. Here m is 2. We need to plug in s, y, and m to solve for b. And for s and y, I can find it from the point here. 1, negative 2. 1 represents s coordinate, negative 2 represents y coordinate. Plugging s and y and m, then solve an equation for b. Here y is negative 2, m is 2, x is 1, then plus b. Solve the equation for b. 2 times 1 is 2. Then I can subtract 2 from both sides. I get b equal to -4. Then plug in b, I can find equation of the line. If I plug in b, I get y equal to 2x minus 4. That's the equation of the line. Next, try to write the answer in the standard form. For the answer in the standard form, we need to move x to the left side, x and y to the left side, and all numbers to the right side. Here I need to move 2s over. If I move 2s over, positive 2s become negative 2x. If I move 2s over, positive 2x become negative 2x. And in general, from the simplest form, we try to make the first number to be positive number. So what I can do here is I can multiply both sides by -1. -2 times -1 will be positive 2. Positive y times -1 will be negative y. -4 times -1 will be positive 4. Multiplying the equation by -1 means we change the sign for every single term. -2x become positive 2x. Positive y become negative y. And -4 become positive 4. That's the answer to this problem. Or we can use point-slope form to find equation of the line. Or we can use point-slope form. Formula for point-slope form is y minus y0 equal to m times x minus x0. In point-slope form, x0, y0 represent a point. M is the slope. Here, slope is the same. Slope is 2. For point 1, -2, we call 1 x0, and we call -2 y0. When we use point-slope form, the point 1, -2 represent x0, y0. Then plug in. I have y minus -2 equal to m is 2, times x minus x0, x0 is 1. Then simplify. Y minus -2 is y plus 2, double negative is positive. On the right side, I can distribute 2. If I distribute 2, I get 2x minus 2. That's the equation of the line. Now, next, try to write the equation of the line in standard form. For the answer in standard form, we move all variables to the left side, move x and y to the left side, and move all numbers to the right side. So here I can move 2s over. If I move 2s over, positive 2s become negative 2x. Y stayed on the left side. Then I move this 2 over. So this -2 stays the same. When I move positive 2 from left side to the right side, positive 2 becomes -2. Then if I simplify, I get -2x plus y equal to -4. And then in general, for the final answer, try to make the first number positive. So I can multiply both sides by -1. Let me change the sign for every single term. I get 2x minus y equal to positive 4. That's the equation of a line in the standard form. So we got exactly the same answer. Part D. Find the equation of the line perpendicular to the line y equal to -4x plus 1 and passing through a point 6, -5. In general, when we try to find equation of a line, we need to know the slope first. In order to find the slope, we can use the formula y2 minus y1 over s2 minus s1 when we know 2 points. If we know 2 points, we can use this formula to find the slope. However, in this problem, we only know 1 point here. That means we cannot use this formula to find slope. In this problem, we know that there's a perpendicular line y equal to -4x plus 1. So we can use this line as a reference to find the slope of the line. This is a perpendicular line. Y equal to -4x plus 1. And we know that slope of this line is -4. If two lines are perpendicular, their slope must be negative reciprocal of each other. If two lines are perpendicular, their slopes must be the negative reciprocal. We know that -4 can be rewritten as -4 over 1. If we try to find the negative reciprocal, change the sign, flip the number over, we get positive 1 over 4. So these two lines are perpendicular. For the slope, we take negative reciprocal, which is positive 1 over 4. These two lines are perpendicular. For the slope, we take the negative reciprocal. That's the slope of the line. Once we know the slope we know a point, we can use slope-intercept form or point-slope form to find quotient of a line. We have two choices here. Either way is okay. Let me show you both ways here. If I use the slope-intercept form, the formula is y equal to ms plus b. Here we know that slope is 1/4. We try to plug in x and y and m and solve for b. For x and y, I can plug in a given point for x and y. The given point is 6, -5. I plug in 6 for x, plug in -5 for y, and then plug in 1/4 for m, solve for b. Here y is -5, m is 1/4, x is 6, plus b. If I simplify, I get -5 equal to 1/4 times 6. It can be written as 6/4. 6/4 I can divide top and bottom by 2. I can make 3/2. Next, I can subtract 3/2 from both sides. Then on the left side here, on the right side I get b by itself. On the left side I get 5, -5 minus 3/2. -5 can be rewritten as -5/1. Then next we try to find the common denominator. For 1 and 2, the common denominator is 2. So for the first fraction, I can multiply top and bottom by 2, which is -10/2 minus 3/2. -10 minus 3. When adding two numbers of the same sign, keep the sign and the numbers. 10 plus 3 is 13. I get -13/2. So here, b is -13/2. Once I know m, I know b. Equation of line is mx plus b. b is -13/2. And in general, for the final answer in the standard form, we need to move x to the left side. We need to move x to the left side. Here x is positive 1/4. Here this term is positive 1/4x. If I move over, it becomes negative 1/4x plus y equal to -13/2. In general, for the final answer in the simplest form, we don't want fractions. So find the least common denominator. For 4 and 2, the least common multiple is 4. So I can multiply both sides by 4. -1/4 times 4 is -1. -1/4 times 4 is -1. Y times 4 is 4y. -13/2 times 4. 4 divided by 2 is 2. 2 times 13 is 26. And in general, we don't want the first term to be negative. So I multiply both sides by -1. -1 times -1 is +1. I get 1x here. -4y equal to 26. That's an answer in the standard form. That's the equation of a line in the standard form. Or for the same problem, we can use point-slope form to find equation of a line. Okay, we can use point-slope form. Point-slope form is y minus y0 equal to m times x minus x0. Here, slope is the same. Slope is 1/4. And for x0, y0, we can use the given point to find x0, y0. The given point here is 6, -5. 6 represents x coordinate, -5 represents y coordinate. And plugging x0, y0, and m. I have y minus y0 equal to m times x minus x0. Then simplify. Y minus -5 is y plus 5 equal to 1/4 x minus 6. That's the equation of the line. Next, try to run the answer in the standard form. For the answer in the standard form, we don't want fractions. Here, the denominator is 4, so I can multiply both sides by 4. If I multiply both sides by 4, I get 4 times y plus 5 on the left side. If I multiply the right side by 4, 4 cancel this 4 here. What's left is 1 times x minus 6. So on the left side, I distribute 4. I get 4y plus 20. On the right side, I distribute 1. I get 1x minus 6. And for the final answer, we try to move x, y to the left side. All numbers to the right side. Move x and y to the left side. All numbers to the right side. If I move positive x over, it becomes negative x. Positive 4y stays the same. If I move positive 20 over, it becomes negative 20. Then here, negative 6 minus 20 is negative 26. So negative x plus 4y equal to negative 26. For the final answer, we try to make the first term positive. For the final answer, try to make the first term positive. So I can multiply both sides by negative 1. If I multiply both sides by negative 1, the sign will be changed. So negative x becomes positive x. Negative 4y, positive 4y becomes negative 4y. Negative 26 becomes positive 26. When I multiply both sides by negative 1, the sign for every term will be switched. So negative x becomes positive x. Positive 4y becomes negative 4y. Negative 26 becomes positive 26. That's the equation of line in the standard form. Number A, part A. Let f of x equal to 3x plus 1. Find f of 2, f of negative 3, f of 4 minus x, and f of 2x squared minus plus 3x minus 1. So, for f of 2, we substitute 2 for x. Replace each x with 2. So I get 3 times 2 plus 1. 3 times 2 is 6. 6 plus 1 is 7. That's an answer of f of 2. For f of negative 3, substitute negative 3 for x. Substitute negative 3 for x. We get 3 times negative 3 plus 1. 3 times negative 3 is negative 9. Negative 9 plus 1 is negative 7. It's negative 8. Negative 9 plus 1 is negative 8. That's the answer for f of negative 3. Next, for f of 4 minus x. For f of 4 minus x, I replace x with 4 minus x. Replace x with what's in the parentheses. So I get 3 times 4 minus x plus 1. That's the setup. Replace x with what's in the parentheses. So replace x with 4 minus x. I get 3 times 4 minus x plus 1. Then simplify. If I distribute 3, I get 12 minus 3x plus 1. Then combine like terms. 12 plus 1 is 13. The final answer is 13 minus 3x. That's the answer of f of 4 minus x. Next, f of 2x squared plus 3x minus 1. F of 2x squared plus 3x minus 1. Replace this x with what's in the parentheses. So I get 3 times 2x squared plus 3x minus 1. Replace this x with what's in the parentheses. Don't forget plus 1. 3 times x plus 1. Replace x with what's in the parentheses. Then simplify. If I distribute 3, I get 6x squared plus 9x minus 3 plus 1. 6x squared plus 9x minus 3 plus 1. And then combine like terms. I get 6x squared plus 9x minus 2. That's the answer for this. Part B. Let f of x equal to 3x squared minus 4x minus 5. Find f of 1, f of negative 2, f of 3x, and f of s plus 1. So for f of 1, we substitute 1 for each x, which is 3 times 1 squared minus 4 times 1 minus 5. 1 squared is 1. 3 times 1 is 3. 4 times 1 is 4 minus 5. 3 minus 4 is negative 1. Negative 1 minus 5 is negative 6. That's the answer for f of 1. Next, f of 2. Replace each x with negative 2. I get 3 times negative 2 squared minus 4 times negative 2 minus 5. Negative 2 squared is 4. 4 times 3 is 12. Next, negative 4 times negative 2 is positive 8 minus 5. 12 plus 8 is 20. 20 minus 5 is 15. That's an answer for f of negative 2. Next, f of 3x. For f of 3x, replace each x with 3x. Replace each x with 3x. So I get 3 times 3x squared minus 4 times 3x minus 5. Replace each x with 3x with what's in the parentheses. Then simplify. 3x squared, if I distribute squared, I get 9x squared. 3 squared is 9. X squared is x squared. Minus 4 times 3x. Do the exponent first. Do exponent first. Then do multiplication. 3 times 9 is 27. I get 27x squared. 4 times 3 is 12. I get 12x minus 5. Then try to combine like terms. If there are no like terms, then we can't combine anything. That's the final answer. Next, f of s plus 1. For f of s plus 1, replace each x with s plus 1. Replace each x with s plus 1. So we get 3 times s plus 1 squared minus 4 times s plus 1 minus 5. Replace each x with s plus 1. Then do the exponent first. Do exponent first. Multiply s plus 1 squared first. What's s plus 1 squared? For s plus 1 squared, we run the same thing twice. That's s plus 1 times s plus 1. S plus 1 squared means s plus 1 times s plus 1. Then distribute. X times x is s squared. X times 1 is x. 1 times x is x. 1 times 1 is 1. Then combine like terms. X plus x is 2x. So s plus 1 squared is s squared plus 2x plus 1. S squared plus 2x plus 1. Do exponent first. Do exponent first. Next, do distribution. If I distribute 3, I get 3x squared plus 6x plus 3. If I distribute negative 4, I get negative 4x minus 4. And minus 5 stays the same. Minus 5 stays the same. Then combine like terms. When we combine like term, start from term with higher power. Here, term with highest power is 3x squared. It cannot be combined, so I leave it the way it is. Next, we have 6x and negative 4x. 6x and negative 4x. Positive 6 plus negative 4 is positive 2. So I get positive 2x. And then 3 minus 4 minus 5. 3 minus 4 is negative 1. Negative 4 minus 5 is negative 6. So the answer is 3x squared plus 2x minus 6. That's the answer for f of s plus 1. 3x squared plus 2x minus 6. Number 9, part A. Let f of x be 2x plus 4. Find the difference quotients. F of 3 plus h minus f of 3 over h. And f of x minus f of 3 over x minus 3. There are two difference quotients. Let's do the first one first. For the first one, f of 3 plus h minus f of 3 over h. I first of all plug in 3 plus h for x. So I get 2 times 3 plus h minus 4. I first of all plug in 3 plus h for x. Then minus f of 3. For f of 3, plug in 3 for x. That's 2 times 3 minus 4 all over h. Then simplify. I can first of all distribute 2. Make 6 plus 2h minus 4. Distribute 2, I get 6 plus 2h minus 4. In the second bracket here, 2 times 3 is 6. 6 minus 4 is 2. That's the second bracket. Over h. Then combine like terms. 6 minus 4 is 2. 2 minus 2 is 0. They get cancelled completely. What's left is 2h over h. Then cancel h from top and bottom. Answer is 2. That's the answer to the first difference quotient. Now for the second one, f of x minus f of 3. For f of x, copy the function. We get 2x minus 4. That's f of x. Minus f of 3. For f of 3, plug in 3 for each x. I get 2 times 3 minus 4 over x minus 3. Then simplify. In the first parenthesis, there's nothing we can do, so leave it the way it is. We have 2x minus 4. In the second parenthesis, we know that 2 times 3 is 6. 6 minus 4 is 2. 2 times 3 is 6. 6 minus 4 is 2. That's the numerator. In the denominator, we have x minus 3. Leave it the way it is. Then combine like terms in the numerator. Negative 4 minus 2 is negative 6 over x minus 3. Now try to simplify this. In the numerator, 2x minus 6. If I factor, I can pull out 2. Write it as x minus 3 over x minus 3. Then we can cancel x minus 3 from top and the bottom. Answer is 2. That's an answer for the second difference quotient. In general, their answers are different. That's a coincidence. In general, their answers are different. Part B. Let f of x be x squared plus 6. Find the difference quotients. F of 2 plus h minus f of 2 over h. And f of x minus f of 2 over s minus 2. So let's do the first difference quotient first. For the first one, we do f of 2 plus h first. That means we plug in 2 plus h for each x. Plug in 2 plus h for x. If we plug in 2 plus h for x, we get 2 plus h squared plus 6. That's the first bracket. That's the first function. Next, for f of 2, we plug in 2 for x. If we plug in 2 for x, we have 2 squared plus 6. That's a numerator. Denominator is h. Then simplify. What's 2 plus h squared? Simplify 2 plus h squared. 2 plus h squared, it means 2 plus h times 2 plus h. If we distribute, we get 4 plus 2h plus another 2h plus h squared. If we combine like terms, 2h plus 2h is 4h. So the answer for 2 plus h squared is 4 plus 4h plus h squared. That's the answer for 2 plus h squared. We have 4 plus 4h plus h squared. That's the perfect square here. Then plus 6. That's the first bracket. In the second parenthesis here, 2 squared is 4. 4 plus 6 is 10. That's the second parenthesis. Over h. Then combine like terms. In general, when we combine like terms, the term with higher power comes first. So h squared comes first. Next we have 4h. 4 plus 6 is 10. 10 minus 10 can cancel completely. So that's the numerator. H squared plus 4h over h. Then in the numerator, I can factor pull out h. If I pull out h, what's left is h plus 4 over h. Then cancel h from top and bottom. The final answer is h plus 4. That's the answer to the first difference quotient. Now for the second difference quotient, do the same thing. It's very similar. For f of x, we copy the function, put it here. X squared plus 6. That's f of x. Minus f of 2. For f of 2, we plug in 2 for x, which is 2 squared plus 6. Plug in 2 for x. That's 2 squared plus 6. Denominator stays the same, s minus 2. Then simplify. In the first parenthesis, s squared plus 6, there's nothing we can do, so leave it the way it is. S squared plus 6. In the second parenthesis, 2 squared is 4. 4 plus 6 is 10. leave denominator the same. Then combine like terms. Combine like terms. We have s squared minus 4 over s minus 2. Now, if we factor the numerator, in the numerator, s squared minus 4, this difference of perfect square, it can be factored as x plus 2 times s minus 2 over s minus 2. Then we can cancel s minus 2 from top and the bottom. What left is s plus 2. That's the final answer to the second difference quotient. Number 10. Graph each of the following functions using transformation of functions and find X and Y intercepts and the horizontal and vertical asymptotes if it exists. Part A. f of x is s squared minus 4. In order to graph this function, let's find the parent function first. For the parent function, we can drop all the numbers, see how it looks like. If we drop all the numbers, what's left is s squared. So we can consider y equal to s squared as the parent function. And we need to memorize the graph of the parent function. The graph of the parent function looks like this. That's the graph of the parent function, y equal to f of x, y equal to s squared. Now, we try to graph s squared minus 4. If we subtract 4 from x, we shift the graph 4 units downward. So if I subtract 4 from x, if I subtract 4 from the function, I shift the graph 4 units downward. Shift 4 units downward if I subtract 4 from the function. So shift the graph 4 units downward. For y equal to s squared minus 4. Shift this graph 4 units downward. It's 0 here. If I shift 4 units downward, 0, 1, 2, 3, 4. So 4 is here. Shift 4 units down, 4 units downward. That's how the graph looks like. Using smooth curves. So that's the graph. Next, find the X and Y intercepts. Here we can see that the Y intercept is negative 4. When I shift the graph 4 units downward, the Y intercept is negative 4. So know that the Y intercept is negative 4. For Y intercept like 0, negative 4. How about the S intercept? In the graph, we see that we have two S intercepts. How do we find S intercept? For an S intercept, set this function equal to 0. For an S intercept, we set this function equal to 0. Y represent f of x. Set this function equal to 0. Set y equal to 0, which means set s squared minus 4 equal to 0. Solve an equation for x. I can add 4 to both sides. I get s squared equal to 4. Then take square root. S equal to positive and negative 2. Square root of 4 is 2. And when we take square root, we need to add positive negative sign. Here s could be either positive or negative 2. Let me have two s intercepts. Which is negative 2, 0 and 2, 0. For s-intercepts, the y-coordinate is always 0. That's the answer for part A. Part B, graph the function f of x equal to negative square root of s minus 4. So let's find the parent function first. For the parent function, we can drop all numbers. If we drop number 4, we drop negative sign. What's left is square root of x. If we drop number 4, drop negative sign in the front. What's left is square root of x. We can consider this as a parent function. And we need to memorize the graph of my parent function. Square root of x looks like this. That's its graph. It terminates at origin, and this side continues. That's a parent function. Now, if we make the entire function negative, I flip the function over the x-axis. If I make the entire function negative, I flip the function over the x-axis. So flip the graph over the x-axis. If I flip over x-axis, this point stays the same. And that's how the graph looks like. That's y equal to negative radical x. If I make the entire function negative, I flip the function over the x-axis. That's the graph for y equal to negative square root of x. Next, if I add 4 to x, I shift the graph 4 units to the left. If I add 4 to x, I shift the graph 4 units to the left. Shift the graph 4 units to the left. This point is 0. If I shift it 4 units to the left, it becomes negative 4. So the endpoint here becomes negative 4. Zero, 1, 2, 3, 4. That's negative 4. That's the graph of the function. That's the graph of the function y equal to negative square root of x plus 4. When we add 4 to x, shift the graph 4 units to the left. Then in the graph we can see that we have an x-intercept, which is negative 4. Also we have a y-intercept here. What's the y-intercept? For the y-intercept, we say s equal to 0. If I say s equal to 0, y equal to f of 0, which means I plug in 0 for x. If I plug in 0 for x, I get negative square root of 0 plus 4. 0 plus 4 is 4. Square root of 4 is 2. So I get negative 2. So the y-intercept here is negative 2. S-intercept is negative 4. Y-intercept is negative 4. Y-intercept is negative 2. So that's the answer. S-intercept is negative 4, comma 0. For S-intercept, the y-coordinate is always 0. And for the y-intercept, the s-coordinate is always 0. So you write 0, comma negative 2. That's the graph, and that's the intercepts. Part C. F of x is 1 over x minus 1 squared plus 3. In order to graph this function, let's find a parent function first. The parent function of this function, we can drop all numbers. If I drop number 1, drop number 3, the parent function is 1 over x squared. So in order to find a parent function, we can try to drop all the numbers. If I drop negative 1, we drop positive 3. What's left is y equal to 1 over x squared. So I can use this function as a parent function. And the graph of this function looks like this. We need to memorize it. That's the graph of this function. And in this graph, there's a horizontal asymptote at y equal to 0. And there's a vertical asymptote at s equal to 0. In this graph, we have two asymptotes, horizontal asymptote and vertical asymptote. Now, try to construct this function based on the parent function. I can first of all subtract 1 from x. If I subtract 1 from x, I shift the graph 1 unit to the right. Vertical asymptote was originally 0. If I shift it 1 unit to the right, it becomes 1 here. So I first of all shift the graph 1 unit to the right. So the new vertical asymptote here is s equal to 1. Horizontal asymptote stays the same. When I shift the graph left and right, horizontal asymptote stays the same. It's still y equal to 0. Next, when I add 3 to the function, I shift the graph 3 units upward. Shift 3 units upward. The function is 1 over s minus 1 squared plus 3. When I add 3 to the function, I shift the graph 3 units upward. It was 0 here. If I shift the 3 units upward, it becomes 3. 1, 2, 3. That's the new horizontal asymptote. It was 0 here. If I shift the 3 units upward, it becomes 3 here. Then sketch the same graph. So here, our new horizontal asymptote is y equal to 3. Vertical asymptote here stays the same. It's s equal to 1. That's the vertical asymptote, and that's the horizontal asymptote. Now in the graph, we can see that there's no s-intercept. This graph doesn't touch the s-axis. There's no s-intercept. And we have y-intercept here. So for y-intercept, we set s equal to 0. Y equal to f of 0. We plug in 0 for x. For y-intercept, set s equal to 0. Plug in 0 for x. If I plug in 0 for x here, I have 1 over 0 minus 1 squared plus 3. 0 minus 1 is negative 1. Negative 1 squared is 1. 1 over 1 is 1. And 1 plus 3 is 4. So the y-intercept is 4. There are no s-intercepts. Y-intercept is 4. For y-intercept, its s-coordinate is always 0. So you write 0, 4. That's a y-intercept. And we have a horizontal asymptote, y equal to 3. Vertical asymptote is s equal to 1. That's the graph, and that's the intercepts and asymptotes. That's the answer for part C. Part D. Graph the function f of x equal to 2 times absolute value of x minus 6. We want to graph this function. Let's find a parent function first. For the parent function, usually we drop all the numbers. We drop -6 on the end. Drop number 2 in the front. What's left is y equal to absolute value of x. Consider this function as a parent function. And we need to memorize the graph. The graph for the parent function here, absolute value of x, its graph is a V shape. For y equal to absolute value of x, its graph is a V shape. That's the graph of this function. Now, next, let's observe here. We have 2 times absolute value of x minus 6. When we multiply the function by 2, when we multiply the entire function by 2, we stretch the graph vertically by a factor of 2. So stretch the graph vertically by a factor of 2. Stretch the graph vertically by a factor of 2. So stretch vertically. If I stretch vertically, the graph looks narrower. If I stretch the graph vertically, the graph looks narrower. If I stretch the graph vertically, the graph looks narrower. So that's the graph y equal to 2 times absolute value of x. Next, when I subtract 6 from the function, I shift the graph 6 units downward. Shift the graph 6 units downward. It was 0 here. If I shift it downward by 6 units, it will be -6. Zero, 1, 2, 3, 4, 5, 6. If I shift the graph 6 units downward, it will be -6 here. That's the graph of this function. Now, in the graph, we can see that we have a y-intercept, which is -6. And we have 2 s-intercepts. Let's find s-intercepts here. For s-intercepts, we set the function y equal to 0. Set y equal to 0. Usually, we say y equal to f of x. If I set y equal to 0, that means the entire function equal to 0. So I have 2 times absolute value of x minus 6 equal to 0. Solve an equation for x. I can first put s6 to both sides. So I get 2 times absolute value of x equal to 6. Next, I can divide both sides by 2. If I divide both sides by 2, I get absolute value of x equal to 3. If absolute value of x equal to 3, that means what's inside? X must be either positive or -3. If absolute value of x equal to 3, then what's inside? It must be either positive or -3. So we have 2 s-intercepts. -3, 0, and 3, 0. We have 2 s-intercepts. And y-intercept here we know is -6. For the y-intercept, its s-coordinate is always 0. So we write 0, -6. That's the graph, and that's the intercept. That's the answer to part D. 11. Solve each of the following system of linear equations. Part A, we have 5x plus 2y equal to 11. Y equal to 6 minus 3x. We try to solve the system of equations for x and y. Let's observe the equation first. In the second equation, we have y by itself. If I substitute y into the first equation, I get equation of x. Then I can solve for x. Once I get x, I can solve for y. So let's substitute first. I get 5x plus 2y. Here y is 6 minus 3x equal to 11. Here y is 6 minus 3x. So I substitute 6 minus 3x for y. Then we have an equation of x. Solve the equation for x. I can first of all distribute 2. So leave 5x by itself. If I distribute 2, I get 12 minus 6x equal to 11. Next, I can combine like terms. 5x minus 6x is negative 1x. 5 plus negative 6 is negative 1. And plus 12 equal to 11. Next, I can subtract 12 from both sides. I get negative 1x equal to negative 1. Then I can divide both sides by negative 1. If I divide both sides by negative 1, I get x equal to 1. Once I know x, I can substitute x here and solve for y. So here, if I substitute x, I get y equal to 6 minus 3 times x. S is 1. 3 times 1 is 3. So y equal to 3. For the final answer, write as s comma y equal to 1 comma 3. S coordinate come first, and then y coordinate. That's the answer to part A. Part B, 6x plus 7y equal to negative 8. 4x minus 3y equal to positive 10. When we have x and y lined up, we can try to use elimination method. Eliminate one of the variable first, and then solve for the other variable. What do we want to eliminate first? Let's observe. Find the least common multiple for the coefficient of x, and the least common multiple for the coefficient of y. For 4 and 6, the least common multiple is 12. For 3 and 7, the least common multiple is 21. So it looks like 4 and 6 has smaller least common multiple. It will be a little easier. So let's try to eliminate x first. Since for 4 and 6 we have smaller least common multiple. Now, what should we multiply 6 to reach 12? We know that 6 times 2 is 12. So multiply the first equation by 2. Next, what should we multiply to 4 to reach 12? We know that 4 times 3 is 12. So multiply the second equation by 3. Next, we want the number to have opposite sign, same value but opposite sign. 6 times 2 is 12, that's positive 12. 3 times 4 is also positive 12. We want exactly the same value but opposite sign. So all I can do is multiply one of them by negative number to make opposite sign. If I take 6 times negative 2, it will be negative 12x here. And on the bottom is positive 12 if I multiply. 3 times 4 is positive 12x. Then multiply negative 2 to the entire equation. Negative 2 times 6x is negative 12x. Negative 2 times 7y is negative 14y. Negative 2 times negative 8 is positive 16. Multiply second equation by 3. 3 times negative 3 times 4x is 12x. 3 times negative 3y is negative 9y. 3 times 10 is 30. Then add the equation together. Add the two equations together. Negative 12x plus positive 12x get cancelled. Negative 14y plus negative 9y is negative 23y. 16 plus 30 is 46. Next, I can divide both sides by negative 23. If I divide both sides by negative 23, y is negative 2. 46 divided by negative 23 is negative 2. That's the answer for y. Next, we need to solve for x. So in order to solve for x, I can substitute y to one of the equation, solve for x. In the second equation, it looks like the coefficients are smaller. So I plug in negative 2 into the second equation. I get 4 times x plus negative 2 for y. I get 4 times x minus 3 times negative 2 equal to 10. Plug in negative 2 for y. That's 4x plus 6 equal to 10. Next, I can subtract both sides by 6. I get 4x equal to 4. Then divide both sides by 4. s equal to 1. So the answer is sy equal to 1 comma negative 2. S coordinate always comes first. 1 comma negative 2. That's the solution to part B. Number 12. Factor each of the following polynomials. Part A. 3x to the power 3, y to the power 5, minus 6s squared, y to the power 4, plus 9s to the power 4, y cubed. So when we try to factor, the first approach is try to take out the greatest common factor. Take out the greatest common factor first. Observe the coefficients 3, 6, and 9. The greatest common factor is 3. That's the largest number that goes into all three numbers evenly. Then common letter is x and y. For x, the lowest power is 2. For x, lowest power is 2. For y, lowest power is 3. So that's the greatest common factor. That's the greatest common factor. Now take it out. When I take out greatest common factor, do division. 3 divided by 3 can cancel. X to the power 3. Take away x squared. What's left is 1x. X to the power 3 means there are 3x multiplied together. If I take out 2 of them, 1x left here. Y to the power 5 means there are 5x multiplied together. If I take out 2 of them, if I take out 3 of them, there are 2 more left here. Next term. Negative 6 divided by 3 is 2. It's negative 2. Negative 6 divided by 3 is negative 2. S squared means there are 2x multiplied together. If I put it outside, no x left. Y to the power 4 means there are 4y's multiplied together. If I take out 3 of them, there's 1 more left. Next term. 9 divided by 3 is 3. X to the power 4 means there are 4x multiplied together. If I pull out 2 of them, there's 2 more left here. Y to the power 3 means there are 3y's multiplied together. If I take out y cubed, there's no y left. That's the answer for part A. Part B. 6s cubed minus 4s squared minus 9x plus 6. When there are 4 terms, we can try to factor by grouping. So group the first 2 terms together and the last 2 terms together. Factor each part individually. For the first half, take out the greatest common factor. Look at the number first. For 4 and 6, the greatest common factor is 2. Then common letters here is x. Choose lower power. For power 3 and power 2, lower power is power 2. So that's the greatest common factor for the first 2 terms. If I pull out 2s squared, what's left? 6 divided by 2 is 3. X to the power 3 means there are 3x multiplied together. If I pull out 2 of them, there's 1 more x left here. For the second term, negative 4 divided by 2 is negative 2. S squared means there are 2x multiplied together. If I pull it outside, there's no x left. So that's the first half. Second half, do the same thing. Take out the greatest common factor. For 9 and 6, the greatest common factor is 3. There are no common letters. And since the first term is negative, pull out negative sign. Then what's left here? Negative 9 divided by negative 3 is positive 3. X stays there. Positive 6 divided by negative 3 is negative 2. Now observe. Here we can see that 3x plus 2 is a common factor. 3x plus 2 is a common factor. If I pull it outside, if I pull out 3x minus 2, what's left is 2s squared minus 3. That's the answer to part B. Part C. S squared minus 4x minus 5. That's a trinomial. When we have a trinomial with no leading coefficient, we can draw 2 parentheses. Put x onto parentheses. Then try to find 2 numbers. When we multiply, we get negative 5. When we add, we get negative 4. Try to find two numbers. Then when we multiply, we get negative 5. When we add, we get negative 4. Here we can try negative 5 and positive 1. When we multiply, we get negative 5. When we add, we get negative 4. So put these two numbers in the parentheses. That's the answer to part C. Part D, we have 2x squared minus x minus 6. That's a trinomial with a leading coefficient. So here we apply AC method. These three coefficients are called A, B, C. These three coefficients, three numbers, they are called A, B, C. Here A is 2, B is negative 1, C is negative 6. We first of all multiply AC. A times C is negative 12. 2 times negative 6 is negative 12. B is here is negative 1. Try to find two numbers. Like when we multiply, we get negative 12. When we add, we get negative 1. We can try negative 4 and positive 3. When we multiply, we get negative 12. When we add, we get negative 1. So these two numbers works. Then rewrite the middle term using these two numbers. Rewrite the middle term using these two numbers. Negative x can be rewrite as negative 4x plus 3x minus 6 stays the same. So leave the first term the same, last term the same. Rewrite the middle term using these two numbers. Negative 4x plus 3x is the same as negative x. Now we have four terms. We can factor by grouping. When there are four terms, we can try to factor by grouping. For the first two terms, take out the greatest common factor. Here, the greatest common factor is 2. And common letter is x. Lowest power is power 1. So pull out 2x. If I pull out 2x, in the first term, if I pull out 2, there's no number left. X squared means there are 2x multiplied together. If I pull out 1 of an x, another x left here. In the second term, do division. Negative 4 divided by 2 is negative 2. There's only one x. If I pull out x, then there's no x left. For the second half, do the same thing. Take out the greatest common factor. For 3x and negative 6, the greatest common factor is 3. And there are no common variables. There are no common letters. That's the greatest common factor. In the first term, if I pull out 3, there's x left. In the second term, do division. Negative 6 divided by 3 is negative 2. And then here we can see that s minus 2 is a common factor. S minus 2 is a common factor. If I pull out s minus 2, what's left is 2x plus 3. That's the answer for part D. Part E. We have 3x cubed minus 12sy squared. For factoring, usually we should take on the greatest common factor first. Take on the greatest common factor first. Look at the numbers. For 3 and 12, the greatest common factor is 3. That's the largest number that goes into both numbers evenly. Next, choose the common letters. The only common letter here is x. And then pick the lower power. Pick the lowest power. For x, for letter x, lowest power is power 1. So that's the greatest common factor. Once I pull out 3x, what's left? In the first term, I pull out 3, so nothing left. S cubed means there are 3x multiplied together. If I pull out one of them, there are 2 more left here. Next, take negative 12 divided by 3. Negative 12 divided by 3 is negative 4. I take out x. No x left. Y squared stays the same. Now be very, very careful. We are not done. Here, x squared is a perfect square. 4 is also a perfect square. 2 times 2 is 4. Y squared is also a perfect square. Since they are all perfect square and we are taking difference, that's called difference of perfect square. That's called difference of perfect square. X squared minus 4y squared. That's x squared minus 2y squared, because 2 squared is 4. Y squared is y squared. That's called difference of perfect square. If we use the formula, it's x plus 2y times x minus 2y. That's how we factor this difference of perfect square. X plus 2y times x minus 2y. That's an answer to part E. Part F. 6x to the power 3 plus 11x squared plus 4x. So when we try to factor, try to take out the greatest common factor first. For 6, 11, and 4, there's no common factors, so leave it the way it is. But be very, very careful. Letter x is common, so I can pull out x. Lowest power is power 1, so x is the greatest common factor. If I pull out x, what's left is 6x squared. X cubed means there are 3x. If I pull out one of them, there's 2 more left here. For 11x squared, if I pull out one of x, another x left here. And for 4x, if I pull out x, there's no x left. What's in the parentheses is a trinomial. It has a leading coefficient here, so I can try to factor this using the AC method. 6x squared plus 11x plus 4. These 3 numbers, they are called A, B, and C. Use AC method, multiply AC first. 6 times 4 is 24. Now try to find 2 numbers that when we multiply, we get 24. When we add, we get 11. Try to find 2 numbers. When we multiply, we get 24. When we add, we get 11. The only choice for us is 3 and A. The only choice for us is 3 and A. 3 times A is 24. 3 plus A is 11. So 3 and 8 works. So keep the first term the same, keep the last term the same. Rewrite the middle term using these 2 numbers. So 11x can be rewrite as 3x plus ax. Rewrite the middle term using these 2 numbers. 11x can be rewrite as 3x plus ax. Then we have 4 terms. We can factor this by grouping. For the first 2 terms, take out the greatest common factor. For 6 and 3, the greatest common factor is 3. And x is a common factor. X is a common letter. So 3x is the greatest common factor. If I pull out 3x, in the first term here, 6 divided by 3 is 2. X squared means there are 2x multiplied together. If I pull out one of an x, another x stays here. For the second term, 3 divided by 3 is 1. There's only 1 x. If I pull out x, there's no x left. So we get 3x times 2x plus 1. That's how we factor the first 2 terms. Then for the last 2 terms here, we have ax plus 4. Take out the greatest common factor for ax and 4. For a and 4, the greatest common factor is 4. There's no common letter, so that's the greatest common factor between ax and 4. If I pull out 4, what's left? A divided by 4 is 2. X stays the same. 4 divided by 4 is 1. So that's how we factor the second half. Now here we can see that 2x plus 1 is a common factor. If I pull out 2x plus 1, what's left is 3x plus 4. That's how we factor this trinomial. We get 2x plus 1 times 3x plus 4. That's the answer to part F.